Auto-obsessed here. Rare opportunity. We've got two technical engineers from RUPES North America. They were in our detailing studio yesterday and trained 16 people on polishing. Today we have them in our video studio and they're going to teach us everything we want to know about RUPES. The history of RUPES, what to know about the polishers, how to use them, the whole system, everything you ever wanted to know, and I'm guaranteed things you never knew before, so stay tuned. So I've got Todd and Alberto from RUPES North America, and Todd, why don't you tell us a little bit of story about RUPES, like how they come apart, a little bit of its history, yeah.
Yeah, some of us in North America may not have been familiar with RUPES before 2012 or 13, but RUPES was actually founded in 1947 in Milan, Italy. And the name itself is an Italian acronym. The S means specialty, if we translate it to English. A manufacturer of specialty pneumatic and electric tools. So that's the English translation of RUPES' official name, but really the emphasis is on the specialty. Since 1947, RUPES' main industry has been making things smooth and shiny. Right. It's what we do.
Right, yeah.
So, of course, a company that's going to come along later and innovate large diameter orbital polishing, or even we created the first gear-driven polisher, that's going to come from a company whose sole focus is on making things smooth and shiny. In fact, automotive paint is about 80% of our industry now.
Right.
So yeah, we were formed in 47. Actually started off originally making electric motors and then transitioned into full body tool manufacturing. In 1961, we came out with the first power tool ever that had a plastic body. So that was a game changer worldwide, right? Yeah. And the thought was, it wasn't to make the tool cheaper. No, it was actually a very expensive tool to produce. But it was because the electrical grid in Southern Europe at the time wasn't so good. So metal tools conducted electricity. Your hair ended up like mine,
okay.
Right? So,
yeah.
But this is just a company that has continuously innovated. So by the time RUPES arrived on the shores of North America late in 2011, people kind of looked at, so who's this tool with this large diameter polisher? But really the foundation was laid 70 years before then, just through a history of innovation. And what we'll talk about a little bit later today is how does the system work and how did all this history come together to create a system that makes paint polish, that really revolutionized paint polish.
Oh, absolutely. I think that's the biggest thing. RUPES, massive game changer. We jumped in on RUPES in 2013. We're a very early adopter and just a game changer in the industry. And every tool manufacturer after that scrambled to reverse engineer and bring out a long throw polisher.
Yeah, so we're most known for our random orbital polishing system and innovation, but RUPES' #1 selling tool worldwide until recently was a rotary polisher. So we are a full line manufacturer. RUPES makes a rotary polisher, we make a gear-driven polisher, we make a number of random orbital polishers in different size and form factors and power supplies.
Right.
So it's a full system, so not just the polishers, but we also manufacture in-house and develop in-house our own pads and polishing compounds. And everything is engineered to work as a system. Again, the S in RUPES stands for specialty. Everybody that works at RUPES is dedicated to making things as smooth and shiny as possible, as quick and easy as possible. So that's what we do. We've done the engineering for you.
Right. One of the things that stood up before, we had conversations before, to me was what you just kind of pointed out. RUPES literally makes almost every aspect of not only the polisher, but everything inside the polisher almost.
Yes.
And the compounds and the pads are specifically made, and the same engineering team obviously is working together as a whole.
Right. We have the European engineering team and the U.S. engineering team, and we work together to develop systems for the markets. The same guys who imagine the polisher are the same ones who are creating the pads, and those pads are designed in the same womb as the polishing compound.
Right.
So instead of some of the competition, they may make a polisher, but now they have to find a third-party pad that kind of works and find a polishing compound that kind of works with the pad.
Yes.
We do everything together, so the results that we expect from our systems are top-notch.
Right. No, that's awesome. Okay, can you explain the different types? We've got a lot of machines sitting here, and,
Right.
and I know that's going to be confusing to people out there. And the names sometimes too, right? RUPES has its own naming standards,
Sure.
I know we get a lot of questions on what's this, what's what's a milli, what's a 19, etc. So why don't you introduce the machines to us, please?
Sure. So still the most popular polishing system worldwide is the Rotary. You'll notice that all of our polishers are called Bigfoot. So Bigfoot originally was the 21 and 15, and then we ported that name into any top-line polishing system we make. So they're all technically Bigfoot polishers, including the Rotary. But the Rotary is the most traditional style of polishing. It's been done for 100 years. Yeah. And our Rotary polisher is very, very lightweight. It's very torquey. It actually has a gear reduction in it. So it can be a little bit noisy, but the torque level is incredible. The problem with the Rotary is the same problem with any other Rotary in the world. Rotary tools inherently create swirl marks, and they have a higher risk of burn. Mm-hmm. So we have an awesome line of pads and compounds designed exactly for the Rotary movement that eliminates a lot of those potential concerns, but those concerns are still there. The random orbital system, so we have the 21 and 15 were the original two. Those came out in 2011 and 2012 with the original ES model. And really, that was on the heels of older, small diameter orbital polishers.
Yes,
in fact, when you and I first started polishing, we were using converted wood sanders.
Exactly.
The Porter cable.
The Porter cable.
Which was great for removing that final swirl, but it didn't really have the energy or the power to take out a scratch.
Yeah.
And vibration levels were quite high.
Vibration machine. Yes.
Sure. So that was the big innovation with the 21 and 15 is now we're moving that pad 2 or 3 times further, which means it's going 2 or 3 times faster. Now it's got the correction ability, but we created a very innovative counterweight to balance it with the pads. So the random orbital eliminates for in most cases, the chance for a swirl mark, which is big. It really reduces the chance of a burn. Can you burn with a random orbital? 100%. But you almost have to purposely try it or work on previously damaged paint. It really reduced the risk. Yeah. And with what made the Bigfoot polishers such an innovation in this industry was it gave us the power to remove actual defects while minimizing vibration. So inside the tool is a counterweight. It's balanced to the weight of the RUPES pads. And when we combine those two, we get a primary balance, so it's very vibration free. The downside of random orbital, honestly, is that because it's balanced to pad size, you tend to need multiple sizes to do all the body panel shapes and sizes efficiently. It is what it is. In between, if we were to marry these two polishers together, you end up with the Miele.
Right.
The Miele is a traditional gear-driven polisher. And what that means is inside the housing unit, the orbit and the rotation are gear-locked together. So every time it spins, it orbits the same amount. It always creates the same pattern. So it really is a marriage of these two. So it doesn't have quite the finishing advantages of a random orbital, nor quite the cutting potential of a Rotary, but it does a great job of striking, a balance in the middle.
Right.
So 3 movements. These two are dual action. This one is a single action Rotary, but when we come to random orbital, because you don't have edge speed and because it's balanced to the pad side, we also have a variety of random orbital polishers, depending on what you're looking to do on that particular body panel.
Now on the Miele too, so the Miele and the Rotary, no clutching systems at all, right?
Correct, yep.
Right? This is
direct
full
drive.
direct drive. Unlike the 2115 where we've got a clutching system, so a bit more safety there. These no clutching at all.
And there's advantage and disadvantage, right? So the advantage of having a driven edge is that you can get into edge work and complex shapes with one tool. Yeah. The risk is a little bit higher because you're using the highest speed of the pad to do the paint correction, but it does give you that ability without downsizing. Right. Yeah. And either one of these tools can kind of accept a variety of pad sizes because they're centrally balanced, especially the Rotary. With the 21, that clutched spinning or that free spinning spindle, it's an advantage and a little bit of a disadvantage. The disadvantage is you have to downsize the tool to maintain enough surface contact flat to get correction. Yeah. But the advantage is it's a safety feature, and also it's the random change of rotational speed that changes the scratch pattern when we're polishing, so we don't see a visible swirl mark. Right. Yeah. So every tool has advantages and disadvantages. When we look at them all on paper, we feel like random orbital is the superior system, as long as you're willing to invest in multiple tool sizes.
Right, yeah.
With so many tool options and movement styles, one of the questions that we get a lot is which is the right tool for the user, and when would they use that tool in which situation?
Yeah, exactly.
Correct. So Todd, you went over all the characteristics of the tools and what they're known for in the movements, but like the question you just asked is, well, the customer may say, well, you have so many, which tool is right for me? Or it could be asked as, what tool is right for the job? So there's sometimes a checklist that you may have when you are interviewing the customer or even interviewing the car, so to say. Situations where maybe you're dealing with thin paint and we need to take that into consideration. So if we know that the rotary tool is the most aggressive and probably the tool that's going to have the most application steps, we need to take that into consideration, and that may answer which tool system we go to. So with those in mind, on that question, we would probably lead into the random orbital tool for that situation there.
And skill level, I mean, skill level would be another one. Someone who's getting into the polishing.
Of course.
Right?
Of course.
Like
new generation polishers or technicians have come into a world where random orbital is kind of the new king of the world, and then there's so many tool options and stuff. But there are some surfaces or some situations out there where another tool system would be beneficial for that application.
Right, perfect.
Yeah, rotary is the leader if you're working on gel coat or both,
for sure.
Heavy oxidation. And although we don't tend to think of the tool in this manner, the fact that it has no offset also makes the rotary a great choice when you're doing precision edge work.
Absolutely.
If you have the skill level
there,
the random orbital often does the job in the least amount of steps, and can be the fastest because of that. And that gear-driven, the melee, it sits kind of in the middle.
It's kind of,
right?
Exactly, yeah. Yeah, no, that's awesome. Okay, so we've got 3 other machines here, so.
Sure, yeah. So these two here are the mini polishers. There's actually a third corded version, but the HLR75 is our newest one. And this and the Nano both feature hybrid technology, which means that they can be used battery powered or they can be used corded. So you have the option with these. In the middle is what we call the Air Mini, or some of us at RUPES call the crazy one. This guy has a 15 millimeter orbit, which is as big as a full-size tool.
Right.
Throwing all that power through a small 100 millimeter diameter face pad.
That's right, yeah.
And can turn at the potential of 11,000 RPM, so almost 2.5 times faster than the 15. So actually, out of every tool we sell, that is the most powerful tool we have. Even though it is random orbital, which is the safest movement, when you supercharge it, it gets a little... So this tool is actually designed at the OEM level to remove scratches and paint damage in less than 15 seconds. That's the time frame. What we're really excited about is this new HLR75. So this uses the same platform and pads as the other 2 mini polishers, but the battery power, it's actually torquier than the corded mini that it replaces. It's lighter by almost half a kilo compared to the LHR75. So it's actually lighter weight and more powerful, and it has a unique new form function. So when people first see this, it kind of raises a few eyebrows. It's got a tall motor with a planetary gear set in here to double the torque, but you can use it single-handed. You can use it two-handed, or even like a palm sander down. So it allows the operator to find what's comfortable for them. And most technicians and end users, when they put it in their hands and use it for a few minutes, the comments that we get are overwhelmingly positive.
Yeah, well balanced.
Super well balanced. Even with the battery in it, it still weighs less than the corded. And then the tool that's all the way to my right is the Nano Hybrid. So this was the first tool we launched in 2015 with hybrid technology. And again, what that means is battery or corded. So now we have 2 hybrid tools. But what made this tool so unique and such a game changer, and followed up on the success of the other game changers, was the movement actually can be changed from 3 millimeter random orbital, 12 millimeter random orbital, or rotary. And if you put this in rotary mode with an extension, you actually have the perfect tool for doing high-end precision edge work, like we talked about earlier in the rotary movement.
This is a phenomenal machine. This one here is absolutely one of the first in Canada. It does have a little bit of wear and tear on it, but
it's good that it's been used.
But to me, and I comment a lot on this one. I mean, this to me is something I think NASA built. You know, it's such a well built machine. It fits so, you know, it fits in your hand so well. The startup, you know, the gradual startup, just the way the speed controller is absolutely amazing. 1 inch, 2 inch. This is a staple in our facility for sure.
One of the things that I found so interesting on this too when we released it was if you look at the way the polishing head comes off the shaft, it's not a 90-degree angle.
No.
It's actually dropped back about 7 degrees. And a lot of study was done in this in finding what was the most comfortable position for the wrist on the paint.
Wrist, good.
Yeah, so every aspect of that tool was engineered for maximum comfort, and not just comfort, but the advantage of a tool like this is we purposely stuck with a small body because now there's other style polishers that have copied some of the features of this, and they're great tools, but they're a larger body, which takes away from some of the versatility you need because you have to be able to place this in areas while maintaining comfort and control.
Yeah, 100%. Not only is RUPES known for their innovative polishing tools, but they also engineer some of the most innovative polishing systems. So why don't you tell us more about their polishing systems?
My pleasure. So in 2009, RUPES started with the Bigfoot project. And the idea of making the orbit larger, from an engineering standpoint, isn't the most difficult. You're basically increasing the arm, the difference between the axle and the spindle, and that increases the orbital length. So that part was actually easy. What was hard to manage was the vibration and the stress that extra orbit, that inertia put on all the components in the tool. And one thing that RUPES learned very early on is the pad is essential for actually managing the energy of the tool. They go together. You really can't have one without the other. And we actually saw this when the Bigfoot first came to the North American market, the 21. The number one complaint we fielded was pads blowing apart.
Yes, yeah.
You're throwing energy through a foam in a pad system that wasn't designed to handle that energy, and you ran into issues with backing plate life, pad life, and overheating of the foam. So foam, by its very nature, the more you move it and the more it compresses and expands, which is what happens doing a dual action movement, the warmer it gets. So RUPES pads are actually engineered to maintain a cooler running temperature, and we do that through the use of a very specific foam, which is reticulated or breathable foam, and having the correct foam stiffness. If you think back to 2009, for those watching your video that may have been detailing as long as you and I have, you may remember that the typical random orbital polisher had an 8mm or a 5/16 inch orbit. Not a lot of energy, so you could use rotary foam pads, which traditionally are softer. It's a softer foam because it just has to spin and change shape fast enough not to dig in to a curve or an edge. The problem is if you take a soft foam like that and you put it on a tool that has a massive movement like the Bigfoot 21, it's going to jiggle on itself like a bowl of jello. It doesn't deliver the orbit to the paint, but instead absorbs that energy, and that absorbed energy in the foam converts to heat. So that's why pads were blown apart. RUPES had to become a foam pad manufacturer out of necessity because the pad had to it. This style of pad now is commonplace. Flared edges about this tall with a hole in the center. In 2011, this pad was made fun of.
Yeah,
I actually remember. It was what a weird pad.
That's right. It was the first pad to look like that.
Yeah, by far. Now this is our second generation DA pad. It is a newer version. So now instead of a straight flared edge, it has a slight bevel or concave curve on it. We found that when you're tilting the pad in to certain curves, it helps distribute the energy a little bit more evenly, which is why we did the running change. But the foam pad was a necessity. If you've had issues with your foam pads coming apart, it's probably the incorrect foam. It is what it is. The other part of the system, and again, as we're engineering the system and developing it, was the Velcro. It's actually, it's not something we think about maybe, but if you don't have the right lateral or shear grip on the Velcro, now that pad is starting to lag behind the backing plate as it's orbiting, and that little bit of wiggle creates a massive amount of heat and friction. And so hook and loop is what it sounds like. It's a hook and a loop, and those hooks get warm and they relax, and now the pad moves more and they relax more. So if you look at the lateral grip, if I attach just a little bit of the hook and loop to the backing plate from the pad, I can actually tear the pad before
it lets go.
Before it lets go. So this was all part of the engineering process of RUPES in 2009, 10, and 11. So the system was developed, but there was one part we were missing. If you've ever run this tool without a backing plate, it jackhammers.
Yeah.
Right.
As soon as you put the correct pad on there, because it's married to the counterweight inside the tool, the vibration is almost negligible. It's almost zero. It's not quite perfect, but near. But you're missing one vital part of the component. And that is when we apply polishing liquid to the face of the foam pad, it increases the weight. So RUPES pads were engineered not with just the weight of the pad, but also the potential weight of the compound. And we had to control the weight of the compound. So the original system was blue, green, yellow, white. You had 4 different foam pads, each with a different cell size, or basically the structure of the foam, how big the pores were. So each of the compounds was viscosity matched to the foam cell size so it wouldn't soak in. Because if it soaked in, the weight goes up, and not only that, but the foam gets softer and you start getting lateral movement. Right. So the whole system was designed in-house to work together.
I think that's some real key points. I know the biggest questions that we get from our customers is, like, why do I need to use the RUPES pads? And you've answered everything. So there's a number of things. So one is the foam type is different.
Specific.
Right? Specific foam type.
And I'm sorry, if I could,
yeah.
Even now, it's a unique foam. So there's a couple of foam pads on the market that are similar colorways to what we offer.
Correct.
But the foams themselves are structurally different. Those are unique foams to RUPES, and they are designed specifically to take advantage of the dual action movement.
Another thing you mentioned, so the Velcro is different, or the hook and loop is different. So this is designed to work with that counterweight system.
Correct.
And hold the pad so there's not any extra friction. That was literally one of the biggest complaints, or not necessarily complaints, but that was the biggest, I would say, breakdown with people. This backing plate, the Velcro no longer holds the pad. The backing plate so they were burning up backing plates.
Right.
They were literally changing color, right? Because of all of that extra friction, and that would have been because we weren't using the right pad.
The right pad.
The next
and even
big
technique, honestly.
And technique, of course.
But the pad.
The fact that this pad is literally balanced specifically for the machine. So this is the 6-inch pad, or the 160 mil, mirrored exactly to go with the 21.
Correct.
Right? So these are really key factors, and I know a lot of our clients, a lot of the users have didn't have knowledge of this before, and it's critical that the RUPES pads are used on this system to get optimum results, save you money, and also reduce the wear on the tool. You're going to have bearing failure,
Yep.
right? You're going to have, over time, you're going to have a bearing failure as well with that extra vibration, right?
It is absolutely the vibration. If you think, and I mentioned technique earlier, if you were coming from a small orbital movement, 8 millimeters, you had to run that thing at full speed with maximum down pressure just
that too,
to get it to go, right?
Yes, yeah.
With a 21 millimeter orbit or a 15 millimeter orbit, and even a 12 millimeter orbit with a little bit smaller pad diameter, there's so much energy being delivered by the tool that it really does come down to the pad structure for life. So when we move out of this world of small orbits and we get into large orbits, the analogy I use is if you have a rock in a string and you hold it in your hand, if it's close to you and you just spin it around, you could do this for days. But if you kind of relax your hand and the string gets longer and that rock starts to develop more inertia as it's traveling further and further away, or a larger orbit away from the bearing, there's more inertia, and that inertia is side load. So if that rope gets too long, you will rip your shoulder out of socket. Well, the same kind of concept is happening with this. So if that pad isn't balanced correctly, and you're running it 10 hours a day for 5 or 6 years, eventually there's a potential for bearing failure if the vibration is not properly managed. But more importantly than even bearing failure, because we can replace the bearing on a tool,
right.
what we can't replace is your shoulder or the nerves in your hand.
Yeah.
We found that certain vibration frequencies absolutely lead to nerve damage and tendon damage, and we're very proud to say that RUPES does not operate, when used as a system, in any of those frequencies. In fact, one of the best stories I can tell, I don't know if you remember this one, Alberto, we were at SEMA, and a large gentleman from Louisiana
Oh, yes.
came up to us, big guy, right? And he's talking to us, and he starts crying, Troy. He starts crying, and Alberto was next to me. I'm actually getting a little bit of goosebumps. Like, do you remember the story?
I do remember.
And he says, I want to thank you. I said, you're welcome. Thank me for what, right?
Of course.
Yeah, no problem. And then he tells us that he was in a car accident, and after the car accident, he had so much nerve damage that he had to close down his detailing business. And now, because of RUPES and our ability to manage vibration, he can provide for his family. And this was one of those good old boys that he didn't want handouts from the government. He wanted to support his family.
Yeah.
Right.
And actually, I'm a little bit emotional because it was just one of those moments where you never think representing an awesome brand like RUPES, you're going to have a guy thanking you for changing his life. And really, it is the marriage of the system that makes it work.
Yeah, great stuff.
You know, that's a lot of great points, and I think that helps. You know, one of the premises of the video is things that you didn't know before, and all of those factors just make complete sense. You know, running the machine with a different pad, you'll know instantly, right?
Sure.
Then as soon as you switch the pads, it's better for your body. You're going to get better results. It's better for the machine, tool life.
Pad life.
And pad life. You know, your
investment.
consumables, right? You're not going to be going through the same amount. So those are all awesome points on why we need to use the RUPES pads with the RUPES systems. And I mean, now we can talk about, you know, how do we put the two together?
Right.
The compounds, and how do we put the pads together, and how do we, because you have an awesome system too on how to prime and how to start the first few moments of polishing.
Yeah, and all of our pads are color coordinated to the compound. Now, you don't have to stick into that system perfectly, although it's a very good basis to start. So blue in RUPES world is coarse, yellow is medium or fine, and then white would be ultra fine, or we also have a number of one-step polishes that have either a wax or a solid nano component in them that are finishing products. And they're all designed to be used together. Originally, like I said, in generation 1, the compounds were viscosity matched to the foam because all we had was foam pads. Now we have foam, microfiber, and wool, so we'll talk a little bit about the differences of those pads. Yeah. And then how do we prime them? Because priming is so important to achieving peak performance immediately. Whenever you polish paint, or I polish paint, what it is, it's an abrasive process. We're removing a defect in the paint, replacing it with a controlled defect. And what we want to do is get maximum performance immediately. So if we think of the old days, a rotary polisher spins. Yeah. And most of the energy is done on the outer edge. So even with our current rotary system. So priming is a little bit less important because as long as we have some liquid on the edge, we're good.
It's good.
With a random orbital, because the movement is this, we want to engage the entire face of that pad with product so that it's all working for us immediately. So we'll cover the priming process for the different pads and how to use them so you guys get the best results you can.
And before we get into the priming, why don't we talk about the pads?
Yeah, RUPES actually in the 3 color coordinated systems, so we have the blue, coarse, yellow, medium, white, fine. There's actually 3 different pad materials. So I'm going to explain a little bit the difference of the pad materials, and most importantly, when would you guys use them? Why would we pick a certain pad for a certain job, right? So total 8 pads. We have the blue line, which is our coarse or most aggressive. So our most aggressive microfiber is blue, our most aggressive wool pad is blue, and again, our most aggressive foam pad is blue. Same with yellow. You may notice that in the white system, we don't have a wool pad, and that's actually because wool as a fabric is aggressive. Gets a little confusing, right? So this is one of the questions we had in your class yesterday. Which pad is most aggressive? The answer is it depends. Right. Because if we look at just the fabrics by themselves, microfiber functionally is the least aggressive. It's a soft fabric we use to grab and pick things up off the surface without scratching. But the reality is when we put polishing liquids, whether it's compounds or polishes, on the microfiber, it becomes functionally the most aggressive. Right. Microfiber makes the compound or polish, or maximizes the compound and a polish's efficiency. Supercharger. Yeah. So think of microfiber pads as the most aggressive option. When would you use them? When you need maximum defect removal. Our blue microfiber features a very unique interface foam, so it's very stiff. It's a little bit of a rough ride. We say it's for spot repair and maximum defect removal, particularly on flat surfaces. Okay. If you want a little bit more give with your microfiber, a little bit taller, you have the yellow microfiber. Fabric's a little different, little more conformability, so it's actually good on curved body panels and different shapes. Also very similar in performance. You can use the yellow with either the blue or yellow compound, the blue compound and yellow polish, and then white is our most conformable foam interface, and also the fabric is designed to maximize the finishing ability of a microfiber, but still a very powerful cutting option. Any microfiber polishing disc does have cutting ability. It's an aggressive fabric. Wool is next. Wool as a fabric is actually the most aggressive material. If you wipe that on polished surface, it can scratch it or haze it.
Yeah.
Wool has natural barbs.
Right.
It's an aggressive fiber. So in our world, the difference between wool and microfiber, because that's the question we get the most, when do I use microfiber, when do I use wool? Microfiber has the most cut, but you also have to clean it the most, because the more cut anything has, the more paint residue is contaminating the pad. So I actually heard one of our colleagues explain it really well. The better the results you get, the more you better clean your pad, because the reason you're getting those results is because you're removing more paint. So wool has almost the same amount of cut as microfiber, but it has two distinct advantages. You don't have to quite clean it as often,
Right.
and also it runs a little bit cooler. Microfiber, lots of surface area, lots of potential heat. So when would I use wool over microfiber? I personally use wool most of the time unless I need maximum cut, or if I'm working on heat-sensitive materials, like carbon fiber, body panels on a Lamborghini, for example, or
Right.
the rubber bumper of just about any car,
Right.
where you have to manage heat. The third material is foam. The blue foam pad is a very coarse, aggressive pad. When would we use the blue foam? Honestly, I prefer the wool for cutting, but when I need to use the blue foam is in any dust-free environment. So let's say you're in an area that installs a lot of PPF film and it's imperative we keep dust migration at a minimum. Foam typically is going to put less dust in the air than any fiber pad that holds more product. Right. The yellow foam is an awesome pad, one of our most versatile pads, great for some level of defect removal, but also on most finishes it creates a great finish. And then the white foam is for finishing exceptionally soft paints and maximizing the mechanical shine, the shine without a wax or a filler. Okay. So just a quick recap, 3 different lines. Use the microfiber if you want the most aggressive cut in that line. So 8 pads in total. Somewhere the yellow microfiber, yellow wool would be middle of the ground. Now, to maximize the performance of our pads and get peak performance right when you start polishing, we recommend priming the pads. And this is super important to get the face of that pad working optimally. We have kind of a unique or specific priming process that's a little bit different for the fiber pads. So microfiber wool is a little bit different than the foam pads. But I want to point out that anytime we prime any of our tools, the Nano, even the Rotary polishers, Miele, 21, you name it, we recommend priming on speed 2 and the application time of about 20 seconds. So those are the standards, but we're going to let Alberto show us how to prime the pads, especially the fiber pad and the foam pad. So Alberto and I are going to switch sides and we'll let him run us through it.
Now we're going to begin the physical priming process of the RUPES system. One quick note again, I know we talked about it earlier, the RUPES pads are an engineered part of the system. All pads, the foam, the microfiber, and wool pad are all balanced to the tools in our system. So we're going to get started here. I'll start with priming the foam pad first. First thing we're going to do is set the tool speed setting to number 2. Now on our foam pads, we will apply an X over the face of the pad. We'll set the tool on the surface, and what we're going to do here is we're going to keep the tool in a small area just about the size of the pad and orbit itself, and we're going to do this for about 20 seconds, and we're going to apply moderate pressure, not heavy pressure, not light pressure. We want to try and make sure the face of the pad makes full contact with the surface. let's inspect our pad. And we can see some spread of the polish around the face of the pad, and we can notice some warmth has built up to an optimal range of operating temperature here.
One of the questions I get, Berto, is when you did the cross, you didn't go all the way out to the edge.
Correct.
You kind of kept it a little bit centered, but it looks like it kind of migrated out. Is that why you did that?
That is correct. One of the reasons I did not go all the way out to the edge is I'm trying to minimize some splatter or some spit, just in case that the foam pad didn't make complete contact to the surface on some curvatures and sort of things. So it's just conscious of that. But I am looking for the spread of the polish around the foam pad. Now, if I don't quite get polish all the way near the edge of the pad, that's okay. This is an area that's not completely supported by the backing plate area, so this is okay. We're not so worried about that ring on the outside edge.
Okay, that's good to know.
Perfect, thank you.
So, Alberto, this is how you prime the pads in the DA system.
Correct.
Right now, you have a different method for the fiber system, so the wool and the microfiber pad.
Sure, the fiber pads are a little bit different and need a little bit different process to spread the compound or polish across the face. So we do have a little bit different process, and we'll show you that now. And take this opportunity also, we're getting ready to take the foam pad off of the backing plate, and as Todd had mentioned earlier, the marriage of the Velcro is very specific to RUPES, and you may notice that the disengagement of the foam pads or fiber pads is sometimes difficult. So RUPES does have a claw pad tool, very unique, a knife shape on one end, and it's also designed to stick the knife between the backing plate and foam pad and help us to remove the pad from the surface here.
I know we see a lot of clients that they just kind of try and grab it, rip it off, and they pull the Velcro from the pad.
Sure.
So
Yeah,
you know, just like what they said, you know, that's a special Velcro system that's designed to hold it and get the maximum grip on the pad so it doesn't move and create extra friction. So the claw tool is a very important piece to the system.
Correct, and when we're polishing, we're creating friction, and foam will tend to hold on to the heat. So sometimes your foam pads are pretty warm when you're done polishing a section. So if you grab that warm foam and just pull on it, you could tear the damage the pad. So now we'll show the process of priming a fiber pad.
it's a little bit different.
Yeah, and again, we want to show the process here. The compound will not spread as easy as it would on the foam here. So what we kind of have to do is, we'll show here, we'll apply a very thin layer across the face of the fibers. And I really want to stress thin. I don't want to see, or we don't want to see large globs on here. But this is probably sufficient right here. So we're doing a little bit of a mechanical spread here with the bottle to get the polish around on the fibers here. Okay. Now the tool speed setting is the same. The area on the surface is the same, and pressure is about the same as well.
So speed to 20 seconds?
Speed to 20 seconds.
Okay.
Wow.
So now what we're looking for is some visual spread of the polish around the fibers, and we can kind of see we did get some good
Yeah, you
spread
can't
here.
even see it, yeah.
Sometimes there may be some dry spots where maybe the polish didn't quite get all to the fibers, and we may have to prime, let's say, a second time.
Sure.
Maybe just apply some polish in that dry area and do the same process one more time and inspect. But now we're ready to go with fiber. So again, fiber pads, we are meaning the microfiber and wool. The process is the same between those two. And then once we're done there, we're ready to start our polishing process.
Yeah, one of the questions I get a lot is when do I need to prime, right? So obviously, obviously if the pad is fresh and out of the bag, it needs to be primed. But let's say we've used that pad, we sit down for a few minutes, or we blow it out with compressed air to clean it, you don't need to reprime. The pad's still wet. Right. The rule of thumb I use, and certainly Alberto, maybe you're a little different, is if let's say they blow it out, they go to lunch, they come back and that pad is dry, a dry pad needs to be primed. That's kind of the rule of thumb. Or if you clean it, or it's the first time it's being used after washed. But we don't need to prime it every time we use it. just when it's
Right.
dry or new.
Right.
Right.
I agree with that. A dry or new pad. Yep.
That's good points. And you know, as I mentioned earlier too, most people will have no concept on how detailed this is.
Sure.
Right? And to be honest, we've always followed kind of that same methodology. You know, you put a few pea-sized drops on the pad. That's a perfect demonstration on why there's two different systems. I mean, if you had just done the X pattern on here, for example, what would we see?
An X.
We would see
Yeah.
an X right now.
Correct.
This is literally, and maybe we'll just throw it here, this is literally completely saturated, right?
And to Alberto's
Right?
point, it's not oversaturated.
It's not
glob
oversaturated.
it on.
Saturated is the wrong
Yeah.
word, right?
No,
But it is
correctly saturated.
It has compound in the entire area. If we would have just did the dots, we would see the dots right now. If you had an X, you would see the X, right?
Right.
And then your demonstration with the foam, we do still see the X, but we do see
Migration of
migration of the compound through it. And again, we didn't know this selling the RUPES system for many, many years. It wasn't until you showed us that. And I think that's something that the audience really can use with the RUPES system. It's a key point. There's a lot of thought in this. And when you see it actually happen, it makes a lot of sense.
Yeah, and even Troy, some of those who had attended our training classes, let's say 6 years ago, we were teaching priming, but what we used to say is do 6 dots around it.
Right.
So even our process has matured as more data has become available. And the
Right.
key point of priming is really just to get peak performance immediately. If we drew an X on this wool pad, for example, then any area that's not covered with polish is not going to work for you immediately. That's the point. We want to get whatever cut the wool has, it'll do, but the rest of the pad is basically neutered.
Right.
Yeah.
So we want to get peak performance immediately.
Sure. So to summarize, and a little bit of an analogy, some of those who are fans of maybe drag racing or something like this, the driver will go out onto the track and do a burnout and get his tires ready for his best run. So it's a similar analogy here. We're getting our pads and temperature in the best window for our best performance right off the bat. So
Perfect.
That's a good analogy, yeah. So that was how we primed the pads using the DA system. And RUPES has a rotary system, so the rotary compounds, rotary pads, and there's a whole different system in priming that, correct?
That is correct. So those customers that are now going to use the rotary systems for maybe different applications, we'll talk about the priming process for this. There are some similarities to priming like we did with the dual action, but then there are some differences as well, so we'll talk about those here. So the first thing, just like on the dual action tools, we'll make sure that the tool speed setting is number 2.
Yep.
So here are some of the differences. If you're using a full-size pad similar to this one here, we recommend applying a bead to the surface about the size of the pad or just slightly larger. Then we'll apply the tool to the surface with a slight till, and what we're going to do here is we're going to move the tool from right to left. This is because of the rotation of the tool itself. Yeah. And then we kind of want to position this in the 10 o'clock to 2 o'clock position, so not quite center over the axis, but the 10 and 2 position of the rotary pad. So then we'll turn the tool on, we'll pick this up, and then after it's picked up, we'll lay the tool flat to the surface. But with this tool, since it's rotary, we have to be very cautious of keeping the tool in place for such an extended period of time, so we may move the tool around the surface just for a little bit. So here we go. And we can see a pretty even spread of the compound around the edges of the surface here. So this would be a successful priming.
Perfect. And I guess you would learn very, very quickly which direction that you move it. If you move from left to right,
sure,
you're going to be spraying compound.
Your area around you would
everywhere.
learn very
So
quickly.
You'd probably
Correct.
do that. You'd probably do that once.
That's actually how you polish the car next to you.
Yeah, exactly. Yeah. No, that was very good. Very smooth.
Yeah, so I think next after priming, then we want to look at some of the polishing basics. RUPES does have a system that we recommend. Now, all of these are variables, but we do talk about section size, pressure, and even arm speed. Arm speed, one of the things, I'd say two things I see people get wrong, and hopefully we can correct that for your audience, Troy, is arm speed and polishing cycle time. So these are really, really big things. So we'll definitely take our prime pad and we'll show you guys how to polish paint the RUPES way.
We just talked about priming on the different tool systems, different pads, microfiber, foam, and rotary and dual action. So now we're going to get started with the test spot. For example, yesterday in class, we get a lot of questions. Wow, you have 8 selections here of pads. Which one do I choose? So the next topic that we go over is the test spot, because usually this answers all those questions related to that. So we'll let Todd get started on.
Yeah, the test spot is really one of the most important and unfortunately one of the most skipped steps of proper application. And the nice thing about talking about the test spot now is we really get to show the RUPES application method. So we're going to kind of kill 2 birds with 1 stone.
Right.
Right here we have 8 combinations if we stay in the color coordination. Now, you had mentioned yesterday in class, we had a trashed car. Everybody that looked at that car said, we kind of did a little survey of the class. What do you think we need? And everybody went to the most aggressive option immediately because the paint was trashed.
Right.
And what RUPES recommends officially is actually starting in the middle. So a test spot is basically the application, a proper application done over a controlled area so we can gauge the results that we expect, right?
Right.
And it gives us a read on the paint, because far too often we see everybody jump for the most aggressive, and what we found in class is actually starting right in the middle was all we needed. So here's the thing with a test spot and moving along the different options. When you do a test spot, which is just an application over a controlled area, you're going to get one of 3 results. Result 1, which is what we got, the holy grail, if you will.
Right.
You do it, you wipe it off, all your target defects are removed, the paint is glossy, and you're ready to apply a wax sealant or coating or whatever your option is for protection.
Right.
Option 2, or result number 2, is you wipe off the residue and you remove the target defects, but the paint is hazy. So DA polishers don't create a traditional hologram, but they create kind of a hazy, slightly unglossy finish.
Or cloudy.
A little cloudy, right? Great, yeah. So in that case, we have a few options. If we're starting with RUPES in the middle with the yellow wool and yellow polish, then we would go to a less aggressive option. So we would repeat the test spot in an adjacent area with a less aggressive combination. Hopefully that will still have enough power to remove the defects, but give us a cleaner finish, and we still stay in that 1 step. If we repeat that test spot with something less aggressive, and we have shiny defects, which is the result number 3. Result number 1 is perfection of 1. Result number 2 is haze. Result number 3 is shiny scratches. So if we try a less aggressive step and we have shiny scratches, then we know that our first step has to go up the aggressive scale. The problem is, the more we go up the aggressive scale, the more likely it is we need a second follow-up step to remove the subsequent haze. So every step more aggressive increases the risk for getting polishing haze, depending on paint color and paint hardness. And then as we go to the coarse end, the option of needing a second polishing step becomes probably more of a reality. So start in the middle. Our recommendation is yellow wool and the yellow polish. Why? Because that gives us a lot of adjustability. We have 3 options less aggressive. We have 4 options more aggressive.
Right.
So that's what I'm going to do now, is talk about a proper application of RUPES, the polishing system. And I'm going to start with the yellow wool and the yellow polish. Now, if you remember, we primed this pad earlier, and priming is the first part of a test spot. Now, this leads to the next question. I have a prime pad. How much liquid do I put on it? RUPES recommends on a large pad, this is a 180 millimeter face or a 150, 160 millimeter backing size, 2 to 4 drops. Pea-sized drops, not large, goblets although I think a goblet is something you drink beer out of if you grow up in Slovakia. But we're not going to do that. We're going to do 4 little drops of polish. And then after that, 2 drops. Why 4? Because I just primed the pad and I want to make sure any area that I might have missed still has a little compound. So 4 drops is more than enough. Now, every time we polish a new section, we want to add new compound. The next question then is, how large of a section am I going to polish? The official recommendation from RUPES is about 6 times the diameter of the pad. So a 21 with a 180 millimeter pad face, it's going to be a larger area than a nano with a 32 millimeter pad face. And that is a standard recommendation for any tool in our system.
Correct.
That is also a variable. When you shrink your polishing size, your aggressiveness goes up. When you make it a little bit larger, you lose some aggressiveness. So you may not even need that much cut. So an adjustment might be a little bit larger area. But for the test spot, it's really good to stick with that, because that's just one of the techniques we can adjust to. After we load the pad, and we know we're polishing an area 6 times the size of the pad, how many passes should I make over that, and for about how long? So the recommendation, again, for RUPES is between, cover that polishing section 2 to 3 times using slow arm speed.
Very slow.
Yep. This is actually the hardest thing for me personally, is I would say painfully slow arm speed. I still, after years and years and years of working at RUPES, have to remind myself to move slow. So we want to cover that area 6 times the diameter of the pad, 2 to 3 times in about 30 to 45 seconds.
Right.
One of the biggest problems we see in polishing world is too much compound. Number 2, way too large of an area. Number 3, way too long of a cycle time. The reality is, when we polish paint residue is going in that pad. It doesn't really matter the compound we're using. The more aggressive our polishing application, the more paint residue we're putting in that pad. And most polishes on the market are going to start losing performance around that 30 to 45 second mark. So we see a lot of people polishing a minute and a half, maybe 2 minutes. You're really losing performance past that 45 second mark, and you're costing yourself time. So we're going to kind of summarize and put all of that together. I'm going to do an area 6 times the size of the pad, covering that area. I can go up and down. I can go left and right. I can cross hatch. I can do both. It doesn't really matter. The tool's orbiting 360 degrees and spinning 360 degrees, so it doesn't really care about the direction you apply it. You just want to make sure you overlap each area and cover each spot in that application area roughly the same amount of time. So whatever you feel most comfortable with, or sometimes even what the car gives you. If you're working on a thin fender, trying to go up and down is really time consuming and not very efficient.
So it could just be left to right or right to left.
Yep, whatever you want to do and whatever works for you. So polishing speed, generally RUPES recommends polishing between speed 2 and 4. So we prime on 2, we do the application 2 to 4. We find most of the time we're going to hit that sweet spot of performance around 3 to 4. So I'm going to start my polishing test spot on number 3. Cord goes over my shoulder. Random orbitals prefer that any part of the pad that's polishing the paint is flat to that surface, so I'm flat. Speed 3. My personal preference is to spread my compound out over the application area so I get a good border and I don't kind of elongate or enlarge my polishing section as I go. That's very common. Some people like to do the dab. If you like to kind of blot the compound on the panel, we would just say, if you're using a foam pad, don't push too hard because you can force compound up into the pad. Or some people like to just start and polish. So I'm going to spread it out. And again, I haven't really started yet my test spot, but just to kind of give me an idea of where I'm at, if I'm on the right spot. 1, 2, 3, 4, 5, 6. So I'm in the right application size, and now we're going to cover that again 2 to 3 times, painfully slow arm speed, moving either left to right or up and down. Now we'll wipe off the residue and inspect our result. And what we're looking for, and we'll use an inspection light, is defect removal and haze in the paint. I can see that it looks like we removed a lot of target defects. There's some deep scratches that are not removable, but there is a little bit of a haze in the paint. So what I would do at this point is move down the aggressive scale and repeat that application area. Again, now it would be the yellow foam, and if we're able to do it in one step, great. If not, we might have to do 2 steps.
Right, so the test spot does a few things. It dials in the process. It teaches us about the surface itself, some trends, maybe hard, soft paint, or those kinds of things. But the last thing that it does is set the expectations to the customer. So the test spot could sometimes be done in front of the customer, and maybe you have your good, better, best program, and you can show them maybe 1-step applications, 2 steps, and then maybe perfection and coding. So the test spot just gives you that opportunity to also dial that portion of the whole process.
So technique, product, customer expectations.
Expectations.
In our opinion, doing a test spot is one of the most vital steps in maintaining an efficient and profitable business.
Absolutely.
One of the most common questions I get, and we talked about it yesterday too, is people want to know what do they need to do to polish their car. And you guys nailed it. Like, the test spot is absolutely critical. You know, we get the call, I've got a 2018, I got a pickup truck, it's blue, what do I need to buy? They don't, primarily people want to know exactly what they need, like what one compound and what one pad, and that's just not a reality. I don't care, how many years experience you have, if you've done maybe a number of those year, make, and models before, regardless of your experience, it's the test system that's going to give us the answer. And I say that all the time. You have to ask the car, right? So doing the test in this exact format gives you the answer you need. You're going to get the results every time. RUPES narrowed it down to basically 3 prime scenarios, right? You've got the white, yellow, and blue. Yes, you can change the pads a little bit, but primarily we've got just 3 scenarios. Right?
Right.
It'll be either 1 of 3, 2 of 3, or 3 of 3 scenarios to give you that answer. And this is perfect. Like you guys spelled it out. Hopefully this helps you learn on how to do the test system to save time, save product, right? Get better results.
Yeah, we really appreciate you having us in here
sure.
and Auto-Obsessed, Troy, and giving us a chance to explain to your viewers a little bit about the RUPES history, the different components in the system, the engineering behind it, and most importantly, the application process, which always starts with the test spot, right? So as long as we follow those, we're very confident with the system that we've provided that you can get the best results in the least amount of time and steps possible.
Right. Yeah, Todd and I are very lucky. We travel a lot and do a lot of training classes, and enjoyed one with you yesterday. And it's a pleasure for us. And the takeaways that the students come away with was, wow, I never really realized. I didn't know I was polishing so long, and I was polishing way too big. So it's really enjoyable for us to experience these things. And again, thank you for having us. And it was a pleasure to be here.
Awesome.
Yes.
Well, I really appreciate you guys, Alberto, Todd, RUPES North America, for obviously supporting this and having such a great partnership with Auto-Obsessed. We've been selling RUPES products now since 2013. We're very proud to be a supplier, distributor of the product. We think it's a phenomenal system. And, again, you guys knocked it out of the park. We heard nothing but great feedback. I had emails this morning from some of the students,
awesome.
How happy they were with that.
We pay for those.
Probably, right?
Yeah,
so
I handed them a 5 on the way out.
Yeah, I can't say enough. Plus, you guys covered it from Florida. We're in Edmonton, Alberta, Canada. Right now, it's really warm for us right now at what was it, -4 yesterday?
A balmy. Yeah.
So for you guys to come out here too, that's huge. We don't get a lot of people coming this far north, and
Awesome.
appreciate that.
Yep.
All of the RUPES products, the equipment, all the tools, the compounds, pads, everything can be found online or in store at autoobsessed.com. Please leave us a comment below. If you like this video, please let us know. Give us a like, subscribe to our channel, leave us a comment. We really would appreciate that. And thank you for watching.
Ciao.
Thank you.
Oh, sorry.